Then the third type of case that you might have come across is when you have an irreducible quadratic in the denominator. So x squared plus 5 cannot be further factorized. It's an irreducible quadratic. So if you were to add the two fractions up, the common denominator is going to be x minus 1 times x squared plus 5. Okay, so I need to multiply this term with x squared plus 5 and this term with x minus 1. So 2 times x squared plus 5 plus 3 times x minus 1. Now, if you solve the numerator, you are going to get 2x squared plus 3x plus 5 plus 10 minus 3 is plus 7 divided by x minus 1 times x squared plus 5. Now, what we are going to learn is the reverse of this. For example, if we have been given this fraction and we want to split it up, so that's going to be the splitting up of this type of fraction in which you have two linear terms in the denominator, two linear factors in the denominator. When you have a repeated factor in the denominator, so x plus 1 the whole thing square, the denominator has a one linear repeated factor. So this type of splitting would be there, because when we add these we get this. Now if we split this up, we are going to get the two terms. And similarly, if you have an irreducible quadratic in one of the fraction, in the denominator of one of the fraction, so the splitting is going to be like this. So in this section, what we are going to learn is how to do reverse of this process. Basically, we are going to learn how to split, or you can say decompose, a single algebraic fraction into two or more partial fractions. So we are going to learn that.
Okay.
So let's start cases by cases. Any questions still here?
No, sir.
Okay. So the first case that we are going to see is proper fraction. Proper fraction where the denominator has distinct linear factors. Distinct linear factors. Now I'm going to call this as case 1. Do you understand the difference between a proper fraction and an improper fraction?
Yeah, so proper would be where it can split, right?
No, proper fraction, for example, 2 upon 5 and 5 upon 2, or let's say 3 upon 2. Which one is a proper fraction?
2 upon 5?
2 upon 5 is a proper fraction. Why is 3 upon 2 not a proper fraction? And it's an
Because
improper fraction, 3 upon 2.
because value is more than 1.
So what you're trying to say is that the numerator is, if the numerator is greater than the denominator, then
Yeah.
you get an improper fraction. And if the numerator is less than the denominator, you get a proper fraction. Now, when we have algebraic expression, if the degree of the numerator, okay, if the degree of the numerator is less than the denominator degree, then you are going to say that the fraction is a proper fraction. Do you understand what I mean by degree of a degree of the
Like the
numerator?
power of that?
The power of the x, yes. So if the degree of the numerator is less than the degree of the denominator, then the fraction is going to be, then the algebraic fraction is going to be proper. If the degree of the numerator is greater than or equal to the degree of the denominator, then the algebraic fraction is going to be called as an improper algebraic fraction. That's the difference. So for the case 1, we are going to look at proper fractions. Just a second. So if we have, let's say, a linear you there's a numerator expression px plus q, and in the denominator you have two linear factors. So it can be splitted as a upon the first linear factor plus b upon the second linear factor. Now this a and b are going to be a constant values. Okay. So if you have this type of fraction in which you have the denominator has two linear factors, then it is going to be split up as a upon one of the linear factor plus b upon the second linear factor. This is the same example as this, a fraction that has linear factors in the denominator. So it was split up as a upon one of the linear factor plus b upon the second linear factor. We just need to find the values of a and b that are part of the numerator. Also, if you have more than two terms, two factors, for example, px plus q upon ax plus b times cx plus d times ex plus f. Now there are three linear factors. So what you are going to do is you are going to write a upon the first linear factor plus b upon the second linear factor plus c upon the third linear factor. If there were four linear factors, you would have done plus d upon the fourth linear factor. That's how simple it is. Now, let's solve a question. Let's say you are being asked to express 2x minus 13 upon 2x plus 1 times x minus 3 into partial fraction. Whenever you receive a question of partial fractions, you first need to check is the fraction proper or improper. So the numerator has a degree of 1 and the denominator will have a degree of
2.
2 because it is going to form a quadratic expression. So the denominator has a degree of 2. So it's a proper fraction and it's a proper fraction with two linear factors in the denominator. So the partial fractions will be of the form a upon the first linear factor plus b upon the second linear factor. Now we want to find the values of a and b. So what I'm going to do is I'm going to solve the right hand side, make the denominators common, and I get a times x minus 3 plus b times 2x plus 1. Now you can compare it with the left hand side. So the denominators are equal. So I'm going to get rid of the denominators. I'm just going to compare my numerator. So I can say 2x minus 13 is equal to a times x minus 3 plus b times 2x plus 1. Now, students have two options over here. Either they expand this and collect the like terms and then compare it, or they take advantage of substitution. So if I want to get rid of a from here, okay, what value of x should I plug in so that this term cancels out?
3.
3, very good. So if I take let x equals to 3, then in the entire polynomial, I'm going to substitute 3. So a will be eliminated and you can directly find the value of b. So this guy is going to be eliminated. 6 minus 13 is minus 7 and 6, that's going to be 7b. So b turns out to be negative 1. Then I can, in order to cancel out b, what value of x should I plug in? What value of x will make this 0? Any idea? If you want this to be 0, you
Oh,
can
half.
equate it to be 0 and solve for x. Yes, so it is going to give you negative half. Yeah. Now, if in the polynomial I'm going to substitute negative half, So I know that b is going to be eliminated. So negative half minus 3. I just need to solve this. Can you solve this and give me the value of a?
Okay, so I'm just doing it.
Yeah.
4.
4. Okay. So a is 4 and b is minus 1. So the partial fractions are now going to be 4 over 2x plus 1 minus
Minus.
1 upon x minus 3. This is how we split up into partial fractions. Now we are going, you will, most of the time you get partial fractions along with binomial series questions. Okay, so part A will be partial fraction and part B is going to be a question on binomial series. So once we are done with all the partial fraction cases, we can look at binomial series as well.
Okay.
Do you need to copy down anything from this slide or should I move on?
No, this is fine. You can move on.
Okay. Now, case 2, is related to proper fractions with repeated linear factors. Factor in the denominator. So, for example, if I have px plus q, but in the denominator I have a linear factor that is repeated. So, ax plus b is a linear factor, but it is being repeated, meaning it's a square term. So we are just going to recall the first slide. If I have a repeated factor, so it was splitted up like this: a upon the one of the linear factor plus b upon the linear factor square. So I'm going to repeat this: a upon x plus 1 without the square term, okay, plus b upon the linear factor squared. So over here, this is going to be a upon first ax plus b only, then plus b upon ax plus b the whole thing square. Okay, so let's do a question at hand. Express 2x minus 11 upon x minus 4 the whole thing square in partial fractions. So again, we are going to ask ourselves, is this an improper fraction or a proper fraction? The degree of the numerator is 1 and the degree of the denominator is 2. So it's a proper fraction. And proper fraction with repeated linear factor in the denominator. So the partial fractions are going to be in the form of a upon,
X minus 4.
yes, and b upon
X minus 4 square.
x minus 4 square. Now it's the same drill. You can just simplify this. A is going to be times by x minus 4 plus b. You're going to equate the numerators. So 2x minus 11 is equals to a times x minus 4 plus b. Now you need to take advantage of this by plugging it in the right value of x to get the value of b. So
Okay, so
let
then,
x be 4, right?
yeah,
So if I'm going to plug in 4, I know this is going to be 0. So b value comes out to be
minus 3.
minus 3. Yeah.
Yeah.
Now your expression will become a times x minus 4 minus 3. After substituting the value of b, you get minus 3. Now, how do you plan on finding the value of a?
Not sure.
You can plug in any value because it's a polynomial, and whatever value of x you plug in, it should be plugged in both sides.
Yeah.
Okay, so the easy value would be let x be 0. If you take x as 0, then you are going to get negative 4a, negative 3, negative 11. So a is going to come out as negative 11 plus 3, 8 divided by 2. A is coming out to be 2.
Yeah.
It wasn't necessary to just plug in 0. You could have plug in 2, any value, because it's kind of an identity, because the left hand side is identical to the right hand side, so it
Yeah.
holds 2 for all values of x. So but
Okay.
you just need to make sure that whatever value of x you are taking, you need to take on both sides and then solve it. So these are the values of a and b. So now, as a final step, your partial fractions are going to be 2 upon x minus 4 minus 3 upon x minus 4 the whole thing square. If you need to note down anything, you can.
No, sound fine.
Okay. Now let's look also a question that has in the denominator a linear factor as well as a repeated factor. So I want you to tell me, how would you be making the partial fractions? What is the form going to be?
So first you break the middle term in the numerator.
Break the middle term.
Yeah.
No, we don't need to worry about the numerator. We just have to deal with the denominators over here.
Oh. Is it gonna be A, B, and C?
Yes, but what the splitted fraction would be a upon.
X minus 2?
Yes. Then
B upon 2x plus 3?
yes,
C upon 2x plus 3 or 2x plus 3 squared?
2x plus 3 squared. So first, this is the combination of the first case and the second case. A upon the linear factor plus b upon the linear factor of the repeated factor, okay, and c upon the repeated factor squared. Make sense?
Yes, sir. Yes, sir.
Now it's the same drill. You are going to solve this. If you take the denominators common, that you are going to get x minus 2 times 2x plus 3 the whole thing square. So a is going to be multiplied by 2x plus 3 the whole thing square. B is going to be multiplied with x minus 2 and 2x plus 3. And c is just going to be multiplied by x minus 2. So the numerator is just going to be 1 minus 9x minus 8x square a times 2x plus 3 the whole thing square plus b times x minus 2 times 2x plus 3 plus c times x minus 2. Now this is where comparing would not have helped you. Only substitution could help you, because if you would have gone for comparing, it would have been a tedious process. First आप इसको expand कर दी, फिर multiply by a कर दी, फिर इसको multiply कर दी, फिर सारे x वाले terms, x square वाले terms separate होते, x वाले terms separate होते, and constant terms separate होते. So it is going to take a lot of time. Now you can save your time by just going for the substitution method. Just plug in, take the right value of x, so that the other b and c can be cancelled out to find a. You getting my point?
Yeah, so what if we were to plug in 2 before for C to find C first?
If you want to find C first,
Or like if we
you
plug X
can't.
as 2 first.
If you plug X as
2 first.
2 first, yes, that's what you're going to do. So if you are going to plug X as 2, so this guy is going to be cancelled out, this is going to be cancelled out, and you are going to get the value of A.
Oh yeah, that's ours.
So I want you to try this on your own. Get me the values of A, B, C, and C, and then I can solve it. We can then compare our answers.
So I've gotten A and C, but I'm not sure how to get B.
Okay, let me help you. So, what's your A coming out?
-1.
-1. Yeah, right. Then you can take, let x be -3 upon 2, right?
Yes.
So 1 minus -3/2 minus 8 times -3/2 square. So -3/2 will eliminate A and will eliminate B.
Yes.
So C
C is
times
1.
-3/2 minus 2. C is 1.
Yes.
Okay. So A is -1, C is 1. Now we know what A is and what B is. So the only unknown that is going to be left is the value of B. So I'm going to rewrite my equation by plugging in the values of A and C. And in order to find the value of B, you can take any simple value of X. Just take it on both sides. So let's take 0. So if you take 0, you get 1 on the left. Is b coming out to be minus 2? Is the value of b coming out to be minus 2?
Yes, sir.
Okay, so the partial fractions are going to be a, which is negative 1 upon x minus 2 minus 2 upon 2x plus 3 and plus 1 upon 2x plus 3 the whole thing square. Any questions till here?
No, sir.
Okay. Should I move on?
Yes.
Case 3. Yeah. Now in case 3 we are going to look at proper fractions but with a quadratic factor in the denominator that cannot be factorized. So we are referring to irreducible quadratic factor. So you are going to come across fractions like in which, let's say, you have been given a linear factor, but along with that you are given a irreducible quadratic factor. If I just go on the first slide, for the irreducible quadratic factor, the fraction was split it up like this. So this is usually given as a upon the linear factor plus, now the form is different over here, bx plus c upon cx square plus d, the irreducible quadratic factor, a upon the linear plus bx plus c upon the irreducible quadratic factor. We are going to start our every question like this. Now it can happen that b value turns out to be 0. There is a possibility. So if b value is gone, then if this is gone, then you are only left with a constant term in the numerator along divided by the quadratic factor, irreducible quadratic factor. So, but you are always going to start off your question by taking bx plus c upon cx square plus d. That's how it goes. Okay, so let's do a question so that you get the idea. You need to express 8 plus 2x minus x square over x minus 1 times x square plus 3. Again, we are going to check, is the degree of the numerator greater or less than the degree of the denominator. So in this case, the degree of the numerator is 2 and the degree of the denominator is 3, which makes it a proper fraction. If it's a proper fraction, then we are going to go with this. This is going to be equal to a upon
X minus.
x minus 1 plus bx plus c upon the irreducible quadratic factor. So we are going to take a start from here, and then it's the same easy steps. Make the denominators common. Now a is going to be multiplied by x square plus 3 and bx plus c is going to be multiplied by x minus 1. If I just compare the numerators, that is going to be equal to this. Yeah. Would you like to try this first?
Okay, sir.
You can simplify this further by multiplying bx with x minus 1 and c with x minus 1, if this helps you.
Okay. So I found A, but I'm stuck on what to do after.
Okay. So how did you find A?
I
By
plugged
taking
in
access
1.
1. Okay. So if you plug in 1, so B and C terms are going to be 0, and this is going to be 4A 10 minus 1. This was x squared plus 3. Okay, my bad. X squared. Oh, I made a small mistake. The question has x squared plus 2. Did you do the entire question by taking x squared plus 3?
Yes, I did. I got 9.
I think, yeah, just correct this question. This is x squared plus 2. X squared plus 2. I think it won't affect the working abhi tak. Just the value of a is going to be changed. So 9 equals to 3a. A comes out to be 3. That's the first step. Now, once you know the value of a, you can take x as 0. So if you take x as 0, on the left hand side you are going to get 8, and on the right hand side 2a plus minus c, and we know the value of a, right? So 3 यहाँ पे plug in कर दें आप. So that is going to be 6. So c comes out to be minus 2. Once you know the value of a and c, your expression is going to be,
So what about BX?
yeah, I'm solving for b now. First I found the value of a using x equals to 1. Then I realized over here that b was
No, so
being multiplied by x. Yes.
when you plug in 0, what happens to BX?
When I plug in x as 0, 0 times anything is 0. So this entire term is going to be 0.
Okay.
So on the right hand side, I have 3 times x squared plus 2. I don't know the value of b right now. C is minus 2 times x minus 1. Now since it's an identity, it is going to be true for all values. So you can plug in any value. So if you just say let x is equals to, हमने 1 ले लिया, 0 ले लिया, you can just take -1. Okay, so if it is -1, so -1 square is 1, that is going to be 3. -2 times -1 is +2b. -2 times -2 is +4. So 5 equals to 9 plus 2b plus 4, and you can find the value of b from here, -4. Let me know if you are getting the same result.
Yeah, I am.
Now the partial fractions are going to be, so a, which is 3 upon x minus 1, plus bx, and the value of b is negative, so plus minus 4x minus 2 over x square plus 2. Now the good way of writing this is going to be 3 upon x minus 1. You can take negative sign common from here, and if you take negative sign common, the entire fraction will have a negative sign, 4x plus 2 over x square plus 2. Do I need to explain anything in this step?
No, sir, I get it.
If you want to note down anything, you can. Then we are going to move on to the next case 4.
Okay, so just give me 1 minute.
Sure, sure.
Yes, I have it down.
Okay. Now, case 4 and the final case is related to improper fractions. Now, you can have improper fractions with linear factors in the denominator. तो ये combination होगा. You can have repeated factor, and you can have irreducible quadratic factor as well. अभी तक हमने जितने भी cases देखे थे, those three cases were related to proper fractions, in which the degree of the numerator was lesser than the degree of the denominator. Now, for improper fraction, the degree of the numerator should be greater than or equal to the degree of the denominator. Even if it is equal, then it's an improper fraction. So, just to give you an example, let's say you are asked to express 2x squared plus 5x minus 11 over x squared plus 2x minus 3 in partial fraction. Now, the first thing that we are going to realize over here is that the degree of the numerator is equal to the degree of the denominator, so it's a it's a improper fraction. Now, for improper fraction, I'm just going to first show you why, and then I'm going to show you how do you do these kinds of questions. So you read this fraction as that the numerator being divided by the Sorry, the screen was gone. Just a
Mhm.
second. Can you see the screen now?
Yes, sir.
Okay. Now, if I divide the numerator polynomial by the denominator polynomial, what would I get? What should I multiply x square with to get 2x square?
2.
2 and just 2.
Yeah.
So 2x square plus 4x minus 6. You change the signs. You get x minus 11 plus 6 is going to be minus 5. Okay. So if you remember the concept of dividend being divided by divisor, giving you a quotient and leaving a remainder, I can replace. Do you remember this?
Yes, sir.
So if I want to replace this, if I want to split it up, then I can split this up as 2 whole
X minus
plus
1.
2 complete wholes plus x minus 5 upon x square plus 2x minus 3. Would you agree with me?
Yes, sir.
And then you can split this up into further partial fractions by by converting x square plus 2x minus 3 into two linear factors. Can you do that for me? I'll just answer my door.
Yes, sir.
All right, so I'm back.
Uh, I got minus 1 upon x minus 1 and 2 upon x plus 3.
Yes. So I can write this as x plus 3 and x minus 1. So I just had this two complete whole over here, and then I can split this fraction into further partial fractions.
Yeah.
So if I do that, this is going to be 2 plus a upon x plus 3 plus b upon x minus 1, and then I'm going to solve it further. Have you solved it?
Yeah, sir, but I wrote A as Okay, never mind. I think it's still right. It's minus 1 upon x minus 1 and 2 upon x plus 3.
Okay, so 2 upon x plus 3 and minus 1 upon x minus 1, right? See,
Yeah.
the only difference you get when you have improper fraction is that the first term, there is going to be a term that has been added. So if I were to make a general rule for this, let's say for example px plus px px square plus qx plus r, just making this up, divided by any, again the quadratic factor ax square plus bx plus c, then the only difference is going to be a plus. Now if you're going to see if this can be further simplified. If this can be further simplified like this into further factors, then you are going to repeat case 1, a b upon the linear factor plus c upon the linear factor, like we did over here. But you are only going to add a constant term always. Are you getting my point?
So can you repeat this part?
Yeah. So for example, if I would have started my question by saying, for the question 2x square plus 5x minus 11 over x square plus 2x minus 3, instead of doing long division, I just realized that okay, it's going to be an improper fraction. So the first step that I'm going to do is I'm going to convert this denominator into, try to convert this denominator into possible further linear factors. So that's going to be 2x square plus 5x minus 11 over x plus 3 times x minus 1 after factorizing. Now, since it's an improper fraction, the only thing I need to do differently is I need to add a constant term, because at that time I don't know what the value is. So I'm going to add the constant term and then I'm going to repeat the same cases with the linear factor. So b upon 1 of the linear factor plus c upon the linear factor. And if I'm going to solve this, okay, that's going to be the case. 2x square
Yeah.
plus 5x minus 11 over x plus 3 times x minus 1. Now I can
And
just compare the
can
numerators.
you do long
Hello?
division to find A?
Sorry, come again.
Is it also acceptable to do long division to find A?
Yes, it's possible. It's possible to do long division. But since after doing long division, we already have to go for this step, so it's advisable that you just go for this comparing steps in the first place.
Okay.
All you need to do is just add a constant term, because there is always going to be a constant term left over here. Okay?
Yes, sir.
If the degree of the numerator and denominator are equal, then there is only a constant term. So, doing the same drill, we are going to find the values of A, B, and C. If I plug in X as 1, this is going to be gone, this is going to be gone. So, I'm going to get the value of C. 5 plus 2 is 7. 7 minus 11 is negative 4. So C is going to come out as negative 1. Now let x as minus 3. You are going to get the same value of b as 2. And if you take, then you can take anything. Let take x as 0 for example, and you already know the value of b and c, so a is going to come out as 2. Okay?
Yeah.
Do you want further practice on partial fractions, especially this case 4?
Uh, um, I think just have one more question.
Okay, just hold on for a minute. I'm going to select a question and give it.
Okay.
Okay, can you see the question now?
Okay.
Yeah, I want you to make partial fraction of this. Just let me know if you think it's a proper or an improper fraction.
Um, Improper?
Improper, yes. Now remember the rules of the improper fraction and you can solve it accordingly.
So I'm not sure how to do this one.
Okay, so you have realized that it's an improper fraction. The degree
Yeah.
of the numerator and the degree of the denominator is same. So the first thing that you are going to do is add a constant term over here. Okay, when the degree of the numerator and denominator are same, instead of going for long division, just add a constant term over here. Done.
Yeah.
Now you're going to recall all the cases of the proper fractions now. So by considering the denominator factors, we were able to identify what case was it. So right now we have a repeated square, that is x square, and we have a linear factor, that is 2x minus 1.
So is that the bx plus c?
So b upon, first of all, b upon the linear factor 2x minus 1. Okay,
Okay.
then c upon the 1. If x square is a repeated factor, just a second, my screen is frozen. I'm going to share it again. All right, is my screen visible now?
Yeah, so
Okay, so what I was saying is that a for the improper fraction case, that is going to be a constant term, plus b upon the linear factor. This is our linear factor. So b upon linear plus c. Now you have x square, that is a repeated square. If you recall, how are we solving for the repeated square factor? This is what we are doing. If we know that a factor is repeated, so first we take a upon the linear factor without the square term, and then b upon the linear factor with the repeated square form. So if x square is the repeated one, you're first going to write x, then you are going to write d upon x square.
Okay.
Sure?
Yes.
Do you want me to explain it again?
No, I get it. This is a repeated fraction.
Yeah. Now you can just solve it and find me the value of AB. Okay, can you try this question from home now? And
Yes,
we
sir.
can look at the solution tomorrow. I'm going to see you tomorrow at the same time, inshallah. Okay?
Okay. Thank you, sir.
Okay, you're welcome. Take care of
Welcome.
this.